time we have seen the method of undetermined coefficient, how to find the solution of the non-homogeneous linear differential equation by the method of undetermined coefficient. And we have seen the example based on this. Now today we want to see the another method. This method is called as the method of reduction of order. And this method is applicable for those differential equation which having the variable coefficient. Up to this, we have seen all the methods only for the differential equations having the constant coefficients. Now, this method and the next method is useful, or with the help of these methods, we are able to solve the differential equation having the variable coefficient also. Now, for this purpose, to see this method of reduction of order, we have to consider second order linear differential equation. We choose the second order for our simplicity to understand this method properly. Y double dash plus px into y plus qx is equal to rx. And suppose y1 of x is any solution of the associated homogeneous differential equation y double dash plus px into y plus q of x is equal to 0. Suppose this y1 of x is the solution of this associated homogeneous differential equation. Then we consider this as, since y1 is the solution of this associated homogeneous differential equation, therefore y1 satisfy this differential equation. We want to use this result later on. Y1 satisfy this differential equation. Therefore, we obtain y1 double dash plus px y1 dash plus qx is equal to 0. And now we take the substitution. Now we change the dependent variable to v by using the substitution y is equal to y1b. In the given differential equation, y is dependent variable and x is independent variable. Now we change the dependent variable y to the dependent variable b by taking the substitution y is equal to y1b, independent variable x as it is. Now here we take the substitution y is equal to y1b. From this, find y dash. Now here there is a slightly mistake in typing. Here it is y dash. It's not y, p of x into y dash. The same way, here it is y dash. Now, by this substitution from this, find y dash is equal to y1 b dash plus y1 dash b and y double dash. Differentiate this, use the product formula y1 into derivative of this is v double dash plus v dash derivative of this is y1 dash. Again, first term as it is y1 dash, derivative of this is v dash, and derivative of this is y1 double dash v as it is, or we combine these two. Now from equation 3, 4 and 5, we substitute this in this equation 1 and we change the dependent variable y to the dependent variable v. By using 3, 4, 5 in 1, we substitute this to be here. Y double dash is y1 v double dash plus 2 y1 dash v dash plus y1 double dash v plus p of x. Y dash is y1 v dash plus y1 dash v plus qx y is y1b is equal to rx. Only we substitute this in the equation 1 from 3, 4 and 5. Now rearrange this equation. We obtain collect the coefficient of v as to be, we obtain y1 double dash plus px into y1 dash plus qx y1 plus y1 v double dash plus 2y dash plus p of x into y1, p of x into y1 into y v dash is equal to rx. But from the equation 2, this bracket is to be 0. Then we obtain only this y1 v double dash plus 2y1 dash plus p of x y1 into v dash is equal to rx. Here it is y1, not y. Here y1 dash. Now this is equal to y1 v double dash plus 2y1 dash plus p of x y1 into v dash is equal to rx. Now we take the substitution w is equal to v dash. Therefore, W dash is equal to V double dash, or you may write V dash is equal to W. Therefore, V double dash is equal to W dash. Therefore, this equation 6 becomes this Y1 W dash plus 2Y1 dash plus PX into W is equal to Rx. With the choice of W is equal to V dash, we reduce the second order differential equation 6 into first order linear differential equation. And we know that how to obtain. First, we divide by y1. To this, we get W dash plus 2y1 dash upon y1 plus P of x into W is equal to Rx divided by Y1. Now this is the linear differential equation of first order in W and X. W is the dependent variable. Therefore, we have to write the solution of this. We know that the solution is what? W e to the power integration of coefficient of W dx is equal to integration of e to the power integration of coefficient of w dx into right hand side dx plus the constant of integration. And we obtain the solution in terms of w and x. Then we substitute the value of w as to be v dash in dv by dx. Again, then after obtaining the solution of this, we obtain the solution in terms of w and x. Then in that solution, we substitute w by v dash means dv by dx. Then we obtain the first order, again first degree differential equation. We solve that first order, first degree differential equation for v and x. Then we obtain the solution in terms of v and x. And then again we substitute the value of v in terms of y. We have chosen y is equal to y1v, means v is equal to y upon y1. Therefore, after substituting the value of v as y upon y1, we obtain the solution in terms of x and y, and then this solution is the general solution of given non-homogeneous linear differential equation by the method of reduction of order. We reduce the order here from second order differential equation, from the second order differential equation into first order differential equation. That's why this method is called as the reduction of order. We reduce the order of this differential equation. I hope you understand this method properly. Again, I will repeat the same method, the method of reduction of order. Now here, for that purpose, for our simplicity, we consider the second order linear differential equation y double dash plus px of y dash plus qx is equal to rx. Now here we assume that y is equal to y1 is the solution of the associated differential equation y double dash plus p of x into y dash plus q of x is equal to 0. Therefore, y1 satisfies this differential equation, we get this equation 2. Now we change the dependent variable y to the dependent variable v by the substitution y is equal to y1v. From that, find y dash, y double dash, and we substitute all these values in the equation 1. Substituting these values in the equation 1, then they collect the coefficient of v, coefficient of v dash, and coefficient of v double dash, we obtain this relation. Now the first bracket is to be 0. Therefore, we obtain y1 v double dash plus 2y1 dash plus p of x into y1 into v dash is equal to rx. Or you may divide by y1, or you may take the substitution w is equal to v dash. Therefore, w dash is equal to v double dash. We substitute this and then divide by y1, we obtain the first order linear differential equation, and we know that its solution is what? W e to the power integration of 2y1 dash upon y1 plus p of x dx is equal to integration of e to the power integration of 2y1 dash upon y1 plus p of x dx into rx upon y1 dx plus C1, or the constant of integration. First, you may take C2, and then we obtain the relation in W and X and first arbitrary constant. Now, then we substitute in this relation W as to be V dash. Therefore, this relation now becomes the first order, first degree differential equation in V and X. And after solving this first order, first degree differential equation, we obtain the relation between v and x. Therefore, now after obtaining the relation between v and x, we substitute in this relation v as to be y upon y1. Then we obtain the relation between x, y, and the two arbitrary constants. And this relation is to be the general solution of the given non-homogeneous linear differential equation of second order. And this is, if we, this method is called as the method of reduction of order. I hope you understand this method properly. In the next lecture, we see the example based on this method. Here, the only one thing is important. We must know one solution of associated homogeneous differential equation. If we know the one solution of the associated differential equation, then and then we are able to use this method. If we don't know the any solution of the associated homogeneous differential equation, then this method is not applicable. Remember this thing. Now we stop our this today's lecture. In the next lecture, we see the example based on this topic, the method of reduction of order.